Okay, hello everyone. Welcome to the second edition of the YAF Talks. During these YAF Talks, we want to create a space for open and engaging conversations about the YAF project. So YAF stands for Yeast-Based Solutions for Sustainable Aviation Fuels. And in the YAF project, we basically investigate how we can use yeast to make oil. And this oil can be made from bio-waste. With this yeast, we made this microbial oil, and the oil can further be converted into aviation fuels, thereby replacing fossil fuels, working towards a more sustainable aviation industry. So in short, in each YAF talk, we want to discuss a specific topic connected to the project. So rather than delivering formal presentations in the sessions, we want really to focus on the conversation. So we will share different perspectives, reflections, and experiences. So therefore, I want to highlight that there are no right or wrong answers. We just want to share our different perspectives, which are grounded in expertise, research, and curiosity of our guests. So we will have two wonderful guests. We have an internal expert from the YAF project, that's Marco. He's one of our PhD candidates. And we will also have an external expert, Kostis. Before I let them introduce themselves, I will give a bit more background on the topic. So the title of today's talk is From Lab to Production Facility, Modeling Full System Approaches for Yeast-Based Sustainable Aviation Fuels. It's a long title, so a bit of an introduction to that. So instead of zooming in on one specific technology of the YAF project, today we will take a step back. We will look a bit at the bigger picture. So this means we will consider the full value chain, going all the way from the feedstocks to the final product, to sustainable aviation fuels, and see how these different steps, the different technologies are combined. And we will discuss how modeling plays an important role in that, doing simulations, also policy considerations, and how this will help understand us, how these yeast-based sustainable aviation fuels can really work at a bigger scale. So maybe before we further kick off, I still need to introduce myself. So I will be the host for this session. My name is Elodie Vlaeminck. I work at Bio-Based Zero Pilot Plant in Belgium as an R&D platform manager. And I'm also one of the supervisors of the YAF project. I have a background in bioscience engineering and a PhD in biotechnology from Ghent University. And my expertise focuses on process development using microbes like bacteria and yeast to convert renewable feedstocks into different kinds of valuable products. And then for the YAF project specifically, we focus on the purification of the oil from the yeast cells. And we at Bio-Based, we also assess the scalability of the biological part of the process, seeing how this can be industry relevant, doing it under conditions that are really used in industry at Bio-Based. And actually, Bio-Based is a perfect place for doing so because we have a lot of experience in scaling different bioprocesses. So with this YAF project, we hope to be able to assess the feasibility of the biological part of the yeast-based aviation fuels. So now finally, I will give the word to you, Kostis and Marco, to let you introduce yourself. Maybe Marco, if you could start introducing yourself.
Yeah, sure. Hi all, I'm Marco Vitale. I have a background in chemical engineering. I got my master's at Politecnico di Torino in Italy. And inside the YAF project, I'm doctoral candidate number 10. And my individual research project focuses on the modeling, optimization, and sustainability assessment of sustainable aviation fuel production routes, going from the feedstocks to the final product of yeast and in yeast-based solution. But as sustainable aviation fuels are a varied environment, I will also focus on these same kind of endeavors for other processes, as for having them as a benchmark to properly assess performance in yeast-based production.
That's clear. Thanks, Marco. And then we also have our external expert, Kostis, here today. Thank you for joining us, Kostis. Could you also introduce yourself?
Thank you, Elodie, and happy to be part of this very wonderful series of talks. I'm Kostis Atsonios. I work at CERT, Center for Research Technology Hellas, since 2010. I have a PhD in engineering, mechanical. My background is on mechanical engineer, and at CERT, I'm mostly involved in projects, and my expertise on design, modeling, optimization of advanced energy systems, mainly focusing on biorefineries or other novel systems for the production of synthetic fuels. And also have been involved in projects related to smart grids and energy storage solutions for all of this towards to an decarbonized systems at both industrial and system level. And the last years I have been coordinating the two Horizon projects. One is the Horizon Europe Fuel Foria project that is still ongoing and dealing with production of advanced biofuels and synthetic fuels with non-biological origin, and the Biosphere project which is focusing on SAF from using syngas from biomass gasification. And yes, and we are also working at trying to build up that experience on that very interesting topics.
Thank you for the introduction. And then maybe I would like to kick off starting a discussion with immediately asking you a question, Kostis, because it's nice to hear that you worked on sustainable aviation fuels using different feedstocks, maybe probably also different conversion technologies, including yeast. So maybe it would be good for the audience if you could explain a bit how yeast can help us to decarbonize aviation, how that process exactly works.
Yeah, well, for those who know so far may not know now, the current technology for the production of sustainable aviation fuels comes from the hydrotreatment of vegetable oils and other oils using hydrogen. When hydrogen reacts with that kind of oils for the production of what we say hydrotreated vegetable oils. Yeast offers an alternative pathway and solution for the production of that kind of the same compounds, as the yeast has the ability to produce this main feedstock that is needed and is processed from vegetable oils for the production of SAF, which is the triacylglycerides. More or less is that in a few words. And the important aspect and things is that yeast, and depending on the process, the different type of microbes that is yeast, we can also start that process from different feedstock.
Yeah, indeed. And maybe I can add there as well that specifically then for the YAF project, we focus on bio-waste as a feedstock. And like you said, for the further conversion of that bio-waste then to the sustainable aviation fuels, of course, if people want to know more details about it, they can check the YAF website. But in short, I will give also a short explanation of that. So within the project, we actually combine two parts. We combine the biological and the chemical part, meaning that in the biological part, it comes first. Those bio-waste are then converted to the yeast into biofuel precursors. And those precursors can be converted in a second part, the chemical part, where they are hydrotreated in a catalytic conversion then to make the sustainable aviation fuels. So that means that actually we have different steps and also different technologies that are combined to get from that feedstock to the final product. So that's why maybe Marco, I can ask the next question to you. Why is it so important then to not only investigate each part separately, but really model the complete flow going all the way from feedstock to product?
Yeah, so it's kind of important because whenever we talk about sustainability, sustainability is a multidimensional problem involving environmental, social, and economical issues. And these kind of issues can be related not only to the things happening inside the plant limits, but are rather systemic phenomena. So we have feedstock producers, maybe, for example, from agricultural activity, and waste coming from this activity is the one that we are hoping to transform through these bio-based processes into sustainable aviation fuels. So we have to transport this feedstock to the plant, and the transport phase is also usually one of the most impacting phase in terms of carbon footprint. For example, there are multiple issues that can arise through phases of the supply chains that are not strictly related to the plant operation. So there's feedstock and the product also to be moved, to be stored. There are social issues to be taken into account when dealing with agricultural production. So when dealing with such varied phenomena, with such varied issues, one cannot just focus on the production plant, and has to have a systemic view built in the analysis they carry out. So basically, that's why we try be wide in the horizon that we analyze, to try not to miss a thing, or at least this is the kind of effort we try to put in our work.
Indeed, so yeah, it's indeed quite complex, and you have to, like you said, take different things into account, like the transport and so on. But that's, for example, also the case for other alternatives, because Kostis mentioned it shortly that you can also use, today vegetable oils can be used as an alternative, for example. There are also other ways to produce sustainable aviation fuels. So from a sustainability perspective, how do these yeast-based sustainable aviation fuels then compare to what's already out there? How could we make a difference? Kostis, if you could maybe comment a bit more on that.
Yeah. So the main difference that can the yeast-based aviation SAF is on the fact that, as I mentioned earlier, the process can be started from a wide spectrum of different feedstock, using, for instance, bio CO2, or from industrial CO2, where if another biological process like gas fermentations can produce the substrate that is needed for the production of THGs from yeast-based processes. The other also important fact is that the triacylglycerides that are produced from yeast have been proven that are quite similar from that are now produced by the conventional vegetable oils. So it's easy to reach to a process where the produced aviation fuel can meet the standards for aviation engines. This is very important, and also compared to other biomass-based fuels like physiotropes, that even though the produced paraffins that are from that thermochemical process like physiotropes or pyrolysis has some can be considered as a kerosene, but don't have all the necessary compounds and characteristics that can be used and fully substitute the conventional oil-based. The most important is that yeast can be a very yeast-based process can be the core chain of a value chain, of a bigger value chain, using different feedstock that, for instance, in Europe, we don't have a lot of feedstock. The feedstock availability for the production of SAF is limited if we based on conventional biomass to liquid approaches.
Okay, interesting. So I think with this, we nicely framed a bit about what yeast-based aviation fuels are and why they could be interesting. So I would like to dedicate this second part of the talk maybe a bit more in depth about the specific research you are doing in this topic. So you both are experts in modeling. So maybe Marco, if you could tell us how this exactly works, like how do you model such a yeast-based sustainable aviation production? What are maybe the important input parameters to look at, or how does this work in practice?
Yeah, for sure. Thank you for asking. I will divide this question into two different dimensions. One more related to the specifics of what happens inside of the production plant, and something that may be more systemic in view, starting from this one. And I would say that keeping in mind that the fuel to be produced is to be sustainable, and keeping in mind that we work in systems analysis, I would say that one of the first thing that comes into mind when dealing with such modeling endeavors, so one of the first thing that has to be decided is precisely the kind of feedstock to be used, because it can heavily affect the microbial processes that are to be used for the transformation. And in this sense, also trying to imagine the future plant location is kind of important, because there may be feedstock limitations at play, and this is usually one of the main issues when dealing with biomass-based production. So I would say that trying to imagine the future plant location and choosing the correct feedstock is one of the most important things when doing the first step in modeling such kind of production. And then when focusing on what happens actually inside the production plant, and specifically into the fermentation unit when the bio-based magic happens, I would say that something to take into consideration is what technicians call the TRI metrics, so titer, rates, and yields. How concentrated then the products that are to be elaborated are at the end of the process, the rate at which the process happens, because at industrial level of production is kind of important that the production is profitable and that the outputs are as much as possible and the yields obtainable, because that's actually like we want to produce as much as possible from as less as possible feedstock amounts, also since we are dealing with sustainability. So I would say that these are the first parameters I try to keep in mind in my work when dealing with bio-based production.
So that means indeed that's especially to get those parameters, you need to work closely together with other doctoral candidates probably, so they have to give you the impacts to make the input to make these models actually, because otherwise.
Exactly. And the YAF project is kind of built to have this collaboration going on. So it's a really nice environment to work in modeling such kind of production, because we have real data coming in. There's a growing literature that complements this internal insight, but it's really important to have early collaboration between different specialists when working with this kind of production processes, in my opinion.
And maybe from your experience, Kostis, do you also have something to add, and what else is important when starting to model such a big concept? So we already had, like Marco mentioned, the location and the consideration of the feedstock, and then also the input parameters of the different technologies. Are there any other important things to consider there?
Yes, from our side at least, we are mostly involved in the scale-up activities. First of all, is to be in contact with the technology experts like that we are a long collaboration in the previous project, to better understand what they are doing at lab at small pilot scale, and based on that to start understanding the behavior of the yeast under the certain variation of operating parameters like the substrate, the different feeding strategies for the feedstock, for the substrate, or to regulate critical parameters like pH, etc. And this give us when we build a robust model that can model and predict that behavior, will give us the confidence to move the technology at a higher scale and scale higher scales. And then we start working and dealing with all the processes that are upstream and downstream, especially for the downstream process for the effective and efficient extraction of the lipids. And also very important to see what happens with the effluent gas and the liquids and their potential valorization.
Yeah, so you mean like the recovery of streams and integration of the different parts and how they could, the synergies maybe, because then it's indeed true when researchers are working on their different technologies, they might not be able to see how they can help each other. Yeah.
Yes, that's our role to integrate, put different experts together and understand the challenges and needs, and in order to optimize and the overall process performance.
And from the work that you've already did, what do you see as the main challenges here for yeast-based aviation fuels then?
Yes, the first, to my point of view, the greatest challenge is to find solutions that could extract and maximize the recovery of the produced yield, because it's not an easy story to and easy thing to extract these triacylglycerides that are produced and remains intercellular. You have to break the cells of the microbes and remove and purify that valuable substance and remove all the other issues that are not needed. Another very important aspect is also to see what happens with the produced CO2, because in principle this is an aerobic conditions, and CO2 is produced during the aerobic fermentation of the yeast cultivation, and maybe this, depending on the composition, the quality of the gas, this will give the opportunity for further valorization and the decrease of the CO2, the carbon footprint of the overall process.
Good point, indeed. It's nice that you mentioned the part about the purification of the oil from the yeast cells, because unfortunately that's often forgotten. People are doing the fermentation, they try to produce microbial oil with the highest start, with the highest product yield, the highest weight, like Marco mentioned, but then we only have yeast and the oil is still inside. And then to couple that to the catalytic chemical process, we need to get the oil out. So that's now within the YAF project, we have at Biobase actually one doctoral candidate, Magda, she's specifically really focusing on that part to really connect the fermentation with the chemistry and making sure that we can deliver and recover most of the oil to have it converted and have also the right purity then for the further chemical conversion. So indeed, a really, really important part. Yes, so yeah, looking ahead maybe, we see that of course there are still a lot of research is needed to have this going, and that's also why we have the YAF project, but also a lot of good progress is being made that we believe that yeast-based aviation fuels could be a solution. What other things do you think are needed to make this into something that can be commercialized? So not only from research perspective, but maybe also from a governmental action or any future policy trends that are maybe ongoing that could support these sustainable aviation fuels. Do you have some input on that, maybe Marco?
Yeah, for sure. There are actually policies in place both at the European level and at the wider international level, and there are policies that try to encourage via different mechanisms the uptake of sustainable aviation fuels, and they try to really encourage, for example, airlines or from one side and fuels producers from the other side to delve into the sustainable aviation fuels scenario. Maybe one future trend that I'd like to see in place in the future years would be a higher level of harmonization of these kind of policies, since they both try to really push production to the actual technical limits and encourage uptake at commercial level. The thing is that the mechanisms through which they work is kind of different, and especially at international level. For example, sustainability requirements in terms of greenhouse gases emissions are lower than at the European level, and that's a good thing that at the European level we really have the ambition to be world leaders in decarbonizing the sector, but it also exposes Europe and us to some kind of commercial risk, because actually these processes are in development, and there are quite well developed processes as waste oil based ones, but for example bio-based ones or more innovative ones that could also take carbon emission reductions further are in development, and these need to be encouraged by signaling from the policy environment to the industrial stakeholders that the ambitions that we have are actually achievable, in terms that I think it's really good to have high ambitions, but it also it's something that can undermine trust in people that have to invest ultimately a lot of money to develop these projects. So from one point, I would say that future trends that I'd like to see are more grounded ambitions that could still take Europe to be one day the world leader in this kind of technologies, but also incentives that could really promote actually feasible technical developments that are so important. And in this sense, I'd like also to see more sustained collaborations between realities such as ours, or all the European-wide projects that are involved in this kind of technologies with the policymakers, to have the dialogue going on and to ascertain in a continuous way that the technological developments are in line with the policy goals that we currently have in place.
Thank you for your answer, Michael. Kostis, do you have something to add there, or do you mainly agree with what Marco says?
I think that Marcos covers all the perspective about around that. The most critical, I think, key message is that the government and the policymakers to understand that sustainable aviation fuels and bio-based or synthetic origin is the only solution to decarbonize aviation. They should pay a lot of effort on that, and to see ways in order to secure the available feedstock, regardless of the technology involved, in order to produce large quantities of SAF. I would like to put more info about that.
Yeah, true, because that's the thing, there will probably not be one solution or one technology that will be able to convert all the different feedstocks. There'll be a combination of different things. So also there, the framework should be there to be able to have different technologies working towards the same goal, having this sustainable aviation fuels. Exactly, unfortunately, our time is up, so we need to finish the conversation. Yeah, for sure, I want to thank you for this conversation. And then, Marco, I will give the floor to you to close this talk as well.
Thank you very much for this space. Are there any really short messages that you would like the people who are watching us to take home as take-home messages in regarding this kind of complex environment in which you are working in? I'll start maybe with you, Elodie.
Yeah, as a take-home message for me, being a researcher myself, being involved in this one specific technology about a biological part, I think I learned from both of you that's important that we need to see the bigger picture, and that also you need us to provide inputs to be able to see that bigger picture, because we can only make that bigger picture if all the individual parts contribute and share that to you. And I think it's really important that the collaboration and it goes both ways, that we not only provide the input, but that we also then listen to you where the main bottlenecks or maybe opportunities, like Kostis mentioned, for example, maybe CO2 is emitted at one part and can be used in another part, how it can be used and how we can integrate this whole value chain to make it as sustainable and also as feasible as possible to do it at a commercial industrial scale. And that's the only way then, I think, to move towards something that can really make a difference. Yeah. So that's it for me, let's say.
Thank you very much for your take-home message. Would you would you like to add something or give us your take-home message, Kostis?
Yeah, my key message from my side. First of all, thank you very much for giving us this opportunity to have this nice and fruitful discussion. Yes, I think that the yeast-based aviation fuels has the potential to become the next big alternative route to produce SAF. Still, there are a lot of things to do, and I think that all the young researchers that are dealing with that area, they can contribute a lot towards the improvement of the overall process. They know very well that where is the main challenge, which is the low titer, the production of targeted terrestrial that are the perfect feedstock for the catalyst processes to produce good and high quality SAF. Yes, I think that we are in a good way, and I think that the next year we will see great results and achievements on that field.
Thank you very much for your input also, and for the hope your messages bring. And it's with hope that I'd like to conclude this talk. I mean, the kind of environment in which we are working in is kind of a complex environment involving a lot of people working in different fields with different backgrounds, and the production flows themselves are quite complex, but it's in complexity that I think lie great possibilities. I mean, if an environment is complex, it means that there are a lot of variable factors at play, and that leaves room for opportunities also. It's not just challenges, but it's opportunities. It's why it's so exciting also to work in such an environment, and I hope on my side that this hope was conveyed to the people who are watching. So thank you very much for your input. I'd like to invite who may be like interested in the topic to get deeper insights and news about the YAF project in our social media pages. We are on LinkedIn. We have a web page, so whenever you want to have more information about the work we are doing here, we will maybe just leave the link in the description of this video. Thank you very much again for giving me the opportunity to have this really insightful talk with you, and for your interesting contributions.
Thank you,
Margo. Thank you, Elodie. Thank you.
Bye.
Bye.